Okay, the subject of this lesson is nested loops. Nested loops, which is a loop inside of a loop. So if you're not comfortable with while and for loops yet, you need to go back and look at the previous two videos and then come back to this one here. Nested loop. So I want to start with an example. Let's write a function. And I'll stick with my black box model of a function where we input capital N and we output an n by n matrix. Call it table, T-A-B-L-E. And this is going to be a multiplication table. So an n by n multiplication table. So if n is 2, this would be 1 times 1 is 1, 1 times 2 is 2, 2 times 1 is 2, and 2 by 2 is 4. So in other words, it's going to take the row times the column, and that's going to be the entry. So this is, for example, this guy here is row 2, column 2, so that is a 4. This guy here is row 1, column 2, so that's 1 times 2, that's a 2. So you can imagine we could have a 10 by 10 multiplication table, and we would have 100 entries there. Alright, so I'll come over here in MatLab and I will go to new function, and we will call this function mult table, and we output table and we input capital N. I will delete the end of the function because it's optional, and I will describe my function. Mult table outputs the n by n multiplication table such that the element at row I, column J is I times J. Put my name, Professor Kump, and the date last updated 4/27/17. Okay. Well, what I want to do is fill in the table. I will start by making a 0 by 0, or not 0 by 0. I will make an n by n table of zeros. Okay, so at the beginning they'll all be zeros, and it doesn't have to be 2 by 2. It can be 3 by 3, 4 by 4, etc. So n is an input, so I need to make an n by n matrix of zeros to start with. So first of all, let me say that table equals, and I'm going to use the function zeros, which I believe is the first time we're using that function. Zeros takes an integer n and outputs an n by n matrix of zeros. So I'll say initialize table. Right? So there we are, initializing the table. Now what I can do is start at the first column of our table. Let me make this bigger than 2 by 2. Let's say for an example, let's do a 3 by 3. What I can do is start at the first column and then loop through all of the rows, and then go to the next column and loop through all of the rows. and then go to the next column and loop through all of the rows. So let's assume that we're starting at column 1, and I want to fill in this entry, then this entry, then this entry. So that's a loop. So I'll say, if we assume we're at column 1, we'll say for I equals 1 to the number of rows. So the number of rows is capital N. So for I equals 1 to N, then the element of table, so this is row I, column 1, equals I times 1, end. Okay, so we're not done yet, but let's consider what happens so far. So let me go back here. When we hit line 10, so remember, before we hit line 10, all of these elements are zeros. When we hit line 10, the for statement says, okay, I is 1. So now we go to line 11, table of 1, 1 equals 1 times 1. So table of 1, 1, that's this guy here, row 1, column 1. So that equals 1 times 1, so that's 1. Then we hit the end of the for loop, so we come back up, and we say, all right, now I is 2. Table of 2, comma 1, so that's row 2, column 1, that's this guy here, is 2 times 1, so that's 2. End the for loop, come back up. I is now 3. Table of 3, comma 1, so that's row 3, column 1, is equal to 3 times 1, 3. End of the for loop there. And for this example, where n is 3, that's it. And so that's the end of the for loop, and because there's nothing else, that's the end of the function. Okay, so as it is right now, these are all 0. This is what our multiplication table would look like. So that's not exactly what we wanted. We want to keep going. So you see, this is a nested loop that we need. We need to loop through the rows, and now we need to loop through the columns. So for each column, we need to go through each row. Then we need to iterate through the column and then go through each row again. So what I'm going to do is, before this now, I'm going to make a new loop for j equals 1 to n. So j is the column index. So we know we have n columns as well. So I'm going to go from from column equals 1, 2, 3, all the way to n. And then I will indent this, because everything in a for loop should be indented. Good practice. And I don't want table of I, comma 1. I don't want to hard code the column as 1. I want to iterate through the column, so this would become j. And I don't want I times 1. I want I times whatever column we're in, so I times j. And then I need to end that for loop. So this is a nested loop, you see. All right, so let's take a look at how this would work now. We delete our matrix elements. All right, so again, on line 7, the multiplication table is initialized to zeros. So if n is 3, we have 9 zeros after that line. Now on line line 9, it says j equals 1 to n. So j becomes 1. Then we come inside and we say for I equals 1 to n. So I becomes 1. And now we say table of ij. So that's table of 1, 1. So that's the element at 1, 1 is 1 times 1. So this element here, right there, becomes 1. And this loop now, the innermost loop, ends, and so we loop back up to line 10, the I iterator. Right? So now I becomes 2. And look, j is still 1. J is still 1. We don't go back up to line 9. We ended this loop, but this loop is still, we ended this iteration of this loop, so this guy is still looping. So I becomes 2 now. We say table of 2 comma 1. That's this element here. Table of 2 comma 1 equals 2 times 1. So that's 2. Then we hit line 12, which ends the for loop, and we come back. And we say, all right, let's let I be 3. So now we've got table of 3 comma 1. J is still 1. So 3 comma 1, that's this element here, row 3, column 1. That's 3 times 1. Or sorry, 1 times 3. No, 3 times 1. 3 times 1 is 3. Now we hit this end, and in our example, n is 3. So we're done looping in the innermost loop. So now we hit the end of the outermost loop, line 13, and we loop back up and set j equal to 2 now. So now j becomes 2. And then we start the innermost looping again. I equals 1 to n. So now I becomes 1. And now we have table of 1 comma 2. 1 comma 2, well that's this guy here. And that is 1 times 2. So that's 2. We hit the end of the innermost for loop, and so we loop back up to line 10 and set I equals to 2. J is still 2. So table of ij is table of 2, 2. That's this guy. Delete that. Table of 2, 2 is 2 times 2, which is 4. We hit the end of the innermost loop, and we loop back up, set I equal to 3. Now we have table of 3 comma 2. So that's this, row 3, column 2. That's 3 times 2, that's 6. Now we hit the end of the innermost loop, and it's done looping. So now we kick out of that loop and come to line 13. We end the outermost loop, and we come back up. And we say, okay, now j is 3. J is equal to 3. And we start the innermost loop again. Set I equal to 1. Table of 1 comma 3. So row 1, column 3, that's this element. That's equal to 1 times 3. And then loop back up, set I equal to 2. Table of 2 comma 3. So that's row 2, column 3, that's this 0. So that's 2 times 3 is 6. And loop back up, set I equal to 3. And we have element 3, 3, and that's 3 times 3, that's 9. Ends the innermost loop, and it ends the outermost loop, and that's the end of our function. And so this is what would be returned. This is our multiplication table. Well, in other words, this is 3 times 3, this is 3 times 2, etc. Okay, so some things I want to point out to you. Number one, notice I didn't use the same iterator for each loop. Okay, I used a different iterator. Here I used J. Here I used I. You don't want to use the same one. That will lead to some semantics errors. You won't get what you expect. So you want to. I think even MATLAB will tell you. Let's see if it tells us. I'll change that to a J. Does it tell us? Yeah, look at. So if I turn that into a J, now I'm using an iterator J and an iterator J. This J is underlined in orange. I don't know if you can see that. But if I hover over it, it says loop index J is changed inside of a for loop. So you don't want to do that. You don't want to mix those two up. So you want them separate iterator variables. And the second thing I want to point out is that it's the innermost loop that is finished first, right? The innermost loop runs first, it completes, and then the outermost loop does its thing. So the innermost loop did 3 times for each outermost loop iteration. So in total, this code went through 9 iterations, 3 iterations for each of the 3 outermost iterations. What would have happened if we switch I and J here? So let's say we go through and change this to I and change this to J. How would that have changed our matrix? Well, the end result would have stayed the same. Of course, it's a multiplication table. The end result would be the same, but instead now of going column-wise, right, the matrix went this way. We filled it up this way. We started here, 1, 2, 3, and so forth. Then we went to the next column. If I interchange the roles of I and J, now we would go row-wise. So we'd iterate through the first row, then the second row. It would go like this: 1, 2, 3, 2, 4, 6, 3, 6, 9. We'd still get the same answer, but the process is different. So I'm going to go back and switch those how we originally had it. Save it. Right, and so now I'll call it. So we'll say table equals mult table, and we'll send it 10. And there's the multiplication facts, a 10 by 10 table. Now, just to show you kind of what's happening, right, just to make sure we do in fact have the right idea of what we did here over in the whiteboard, let me clear the command window, clear the workspace, and I'm going to leave off the semicolon in the critical line here, line 11. So it's going to echo back to me every time it computes a new element of the table. And I'll even leave the semicolon off in line 7 where we define the table of zeros. So I'll save that. Right. So every time it loops now, it's going to display what the table is. Oops. No. So we'll say multiplication table of 10. So it looped 100 times. Right? 101 if you count the original initializing of the matrix. So here are the table of zeros. And see, notice the first time through it starts there. And it proceeds column-wise. Now we've got a 2 there. Now we've got a 3 and a 4 and so forth. When that first column gets filled up. Then we go to the second column, and so forth. All the way to this guy here. Now, just to demonstrate what happens if we switch the roles of I and J. So let me call that I, let me call this J, and save it. And now let me call my multiplication table. Come back up here. And you see we've got our matrix of zeros, and we start here at the 1. But now look at, we're proceeding row-wise. 1, 2, 3, and so forth. Here's the first row is filled. And then we come down to the second row, and so forth. So we still get the same answer, it's just two ways of doing the same thing. So I'll put those semicolons back on. And just to demonstrate its correctness, let's say maybe I want a 1-by-1 multiplication table. Yep, there's my table. Maybe I want a 5-by-5 multiplication table. There it is. Okay, so it works for any positive n integer. The second example I want to look at is let's write a sorting function. I want to input, so here's my black box again. I want to input a vector, call it v, and output v, but sorted, we'll call it vs. Sorted in we'll say ascending order. We can choose one. We'll do ascending order. Okay, so for example, let's say I have a vector 100, 50, -7, -2.5. I want to sort that in ascending order. Right. So what I can do is compare element 1 with element 2. So this is the algorithm. So I'm going to compare element 1 with element 2. If element 2 is less than element 1, I'll swap them. Okay, so compare elements 1 and 2. 1 and 2. If v of 2 is less than v of 1, swap. Okay, in this case it is. And so after that swap, our vector would look like this. Then you can see now this is a looping idea. Now I want to change in a predictable pattern. I want to compare now elements 3 and 2. So if v of 3 is less than v of 2, swap. So element 3 here is in fact less than element 2. So now I'm going to swap. And similarly, if v of 4 is less than v of 3, I'm going to swap. And it is. So after I would swap those guys, it would be 50, -7, -2.5, 100. Now I'm done with the first pass. Is my vector sorted? Nope, it's not quite sorted yet. Okay, but what happened was that the largest value, which was 100, made its way all the way to the right. So the 100 is in its final position. But now I need another pass. So this was one loop. Right? We compared v of 2 to v of 1, then v of 3 to v of 2, v of 4 to v of 3. That's one loop. And that's a for loop, because the numbers are following a predictable pattern. Right? We're changing v2, then v3, then v4. And I know ahead of time how many times I have to loop. I have to loop the length of the vector minus 1. Right? Because I perform 3 comparisons in this example, and the length is 4. So I know how many times I have to loop for each pass. Now the question is, how many times do I have to make a pass? For example, now I have to do that again. Compare v of 2 with v of 1. And if v of 2 is less than v of 1, swap. Okay, so in this case it is. So now after that swap, the -7 goes here, and then I have the 50, the -2.5, and the 100. Then compare 3 with 2. So now 50 and -2.5. So -2.5 is less, so then I would swap those. Then compare v4 with v3. And in this case, I don't need to swap. Right? Now, my vector happens to be sorted now, so I can stop. But what I want to do in my algorithm is I want to make one more pass. See, we're human, so we're looking at that and we say, yeah, it's sorted. But a computer doesn't know that that's sorted yet until it does this looping again, and it looks at this comparison, and it doesn't need to perform a swap. Then it does this comparison, and it won't perform a swap. And then it looks at this comparison, and it won't perform a swap. Then we say, okay, because I didn't swap at all, I know that it's sorted. So there's two loops going on here. There's this for loop where each pass I'm looping the length minus 1 times. Then there's another loop that I'm looping while I'm performing a swap. So for every pass, if I performed a swap, I need to make another pass. Now in this case, I didn't swap, so now I know that I don't need to make another pass and I'm done. That's how the algorithm is going to work. That's called a bubble sort, by the way, because the extreme value bubbles to the top. Right? After this first iteration, the 100 got here. After the second iteration, the next largest got here, and so forth. That's called a bubble sort. All right, understanding that now, we'll move to the function. So let me X out of this, clear the command window, clear the workspace, and I will write a new function, call it mySort. And the output argument will be vs, and the input argument is v. I will get rid of the end of the function, and I will type a summary. MySort sorts a vector in ascending order. Put my name and the date. All right. And I'll save it. Save as mySort. Right now we're going to put into code exactly what we just described in English on the whiteboard over here. Except we're not going to assume the length is 4. We need this to work for any length vector. So the first thing we might want to do is get the length of the vector. So we could say len equals length of v. All right, so one pass. Let's just try to knock out this for loop here. Make one pass. So what we're going to do is start at the iterator I equals 1. So we'll say for I equals 1, and we know we have to loop the length minus 1 times. I went through that already. So we're going to say for I equals 1 to length minus 1. And we're going to compare v of I, okay, currently I would be 1, with I plus 1, v of 2. So we're going to say if v of I plus 1 is less than v of I, and I'll comment, then we need to swap. And we've done swapping a few times here, so I will do this quickly. V of I is temp. V of I becomes V of I plus 1, and then V of I plus 1 becomes temp. Okay, so did I do that right? V of I plus 1? Yes. That will swap V of I with V of I plus 1. And we'll end that. Alright, so let me come back to the whiteboard here, and let's consider this same example case. And I'll delete some of this here. Alright, so with that same example case, let's look what's happening in our function as it is right now. It's not complete yet, but let's look at it. So if this were the vector that I send my function, on line 6, len is 4. Let me back up here, len 4. Now, line 8, for I equals 1 to len minus 1. So now I becomes 1. And we say if v of 1 plus 1, so that's v of 2. So here we'll say v of I plus 1. And we'll say v of I. So v of I plus 1 is 50. And v of I, because I is 1, is 100. So if v of I plus 1 is less than v of I, so is 50 less than 100? Yep. And so then I do my swapping routine. So now this would become 100, and this would become 50. End the swapping routine, then end the for loop. So I loop back up. Now I becomes 2. V of I plus 1 now is -7. So this is what the vector looks like currently after that first swap. So v of I plus 1, that's v of 3, is -7. V of I is 2. V of 2 is 100. So is v of I plus 1, -7, less than v of I, 100? Yes, it is. So then we enter our swapping routine. So this becomes 100, this becomes -7. We end the swapping routine, end the for loop. And we loop back up and set I equal to 3. Now the vector looks like this. We say v of I plus 1. Well, I plus 1, I is 3, so v of I plus 1 is -2.5. And v of I is 100. So is v of I plus 1 less than v of I? Yep. So I enter the swapping routine. I swap those guys. End the swapping routine. Now the vector looks like this down here. And the for loop was to go from I equals 1 to length minus 1. So LEN was 4. 4 minus 1 is 3. So I was not to exceed 3. So I'm done with that for loop. And as it is now, I'm done with the function, because there's nothing after the for loop. So this is what my vector looks like now. That was one pass. So in this case, I need to keep making these passes, right? So long as I have swapped. So what I'm going to do is we're going to call it a flag. We're going to raise a flag. We're going to say swapped equals 1. I'm defining a variable called swapped. And so if I make a swap, we're going to set it equal to 1. So that's going to tell the program that I'm still swapping and it's still not sorted yet. And we're going to continue this routine then while swapped equals 1. So I'm using the double equal sign again because we're testing to see if swapped is equal to 1. And then it's underlined in red, it needs an end. So all of this passing, right, that made one pass, all of that pass needs to be contained in the while loop because I need to keep making passes while I'm still swapping. So all of that needs to be indented. There we go. Now I have a couple issues here. The first issue is I'll get a syntax error because the very first time this runs, so as soon as we call it, it's going to hit line 8 and it's going to say, well, what is swapped? Is swapped equal to 1? Well, we haven't defined swapped yet. Right, so we're going to get a syntax error, undefined function or variable swapped. In fact, it tells us, it's underlined in yellow orange. It says the variable swapped might be used before it is defined. We want it to start the swapping routine. So we're going to set swapped equal to 1 right there. And the purpose of that, I'll comment it, to enter the while loop. So now, you see swapped is not underlined in orange. Swapped is 1, so line 9, while swapped is equal to 1. Okay, it is equal to 1, so now we're going to start the swapping routine, or at least the comparison. We're going to make a pass. And now that we're in that routine, now we want to reset the swapped flag to 0. We're going to say reset swapped flag. We're going to say, all right, now that I'm starting this routine, I have not swapped anything yet. So we're going to say swapped is 0. And we're going to make this pass. If we get done with this routine, if we get done with that pass, and swapped is still 0, then we know it's sorted already, and I can stop. I can exit my while loop and stop. Alright, let's go through this loop by loop. I will write the example up here. 150, -7, -2.5. There it is. And we'll go through all of these by hand. Okay, so we will say length. We'll want to know what length is. We'll want to know what swapped is. We will want to know what I is. We will want to know what v of I is. V of I plus 1. And temp. Alright, so let's see if we can track all of these variables as we're looping. Alright, so for this vector that comes in. Line 6, length equals, len equals length of v. Okay, so len is going to be 4. Now, line 8, swapped is 1. So we've initialized swapped. Line 9, it's going to test to see if swapped is 1. Yes, it is. So we enter the while loop, and we're going to immediately reset swapped to 0, now that we've entered the while loop. Say, well, we haven't swapped anything yet. Now, for I equals 1 to length minus 1. So I is 1 currently. If, okay, this is true. So v of I is 100. v of I plus 1 is 50. So if v of I plus 1 is less than v of I, so is 50 less than 100? Yes. So now v of I, I have a mistake here. This needs to be temp equals v of I. We're going to set temp equal to v of I, so that's 100. Now v of I becomes v of I plus 1. So now v of I is v of I plus 1, which according to our table is 50. On the next line, v of I plus 1 becomes temp. So temp is 100, so now this is 100. See, so we've swapped those two. And then we're going to say, hey, I swapped something. So we're going to raise that flag. Yep, swapped. End the swapping routine, which is the if statement. Now here's the for loop. We're going to go back up. I is equal to 2 now. So, well, actually, that was the first iteration. So now I is 2. V of I plus 1. Okay, so I is 2, so I plus 1 is 3. So V of 3 is negative 7. V of I is now, so we swap those two. So our vector looks like this now. So V of 2 is 100. Is, or if, I plus 1, V of I plus 1 is negative 7, is less than I, V of I, 100. Swap. Okay, and that's true. So we're going to say temp is V of I, so temp is 100. V of I is V of I plus 1, so this becomes negative 7. V of I plus 1 becomes temp. And swapped becomes 1. Well, it already was 1, so it's 1 again. And the swapping routine, and then the for loop. Here's the for loop end, so we come back up. Set I equal to 3. Now my vector looks like this. With I equal to 3, V of I is 100. V of I plus 1 is negative 2.5. So if V of I plus 1 is less than V of I, so negative 25 is less than 100, so we enter the swapping routine. Temp is V of I, so temp is 100. V of I equals V of I plus 1, so this becomes negative 25. And then V of I plus 1 is equal to temp. And swapped still stays at 1. And that's the end of that loop. Now, I was only to go to length minus 1. So length minus 1 is 3, and I is 3. So we're done with that for loop. And now we're at the end of the while loop. We said, did we swap something? Okay, while swapped is 1. And yes, we did swap something. Swapped is 1. So we need to continue swapping. So we come back up. Go to line 9. Yep, we're still swapping. So now we go to 11. reset the swapped flag to 0. I'll make it kind of a double because that's the end of the while loop. So set swapped equal to 0 for I equals 1. Okay, v of I plus 1. Okay, so now our vector looks like this. Nope. Negative 2.5 to 100. Okay, so v of I is 50. V of I plus 1 is negative 7. Because v of I plus 1 is less than v of I, we want to swap. So temp becomes v of I, 50. V of I becomes negative 7. V of I plus 1 becomes temp, which is 50. So we've swapped now. So I'm going to write that up here. So now our vector looks like this: negative 7, 50, negative 2.5, 100. And let me delete these guys. Okay, so now I end that swapping routine. There's the end of the 4. I need to come back up. I becomes 2. I becomes 2. V of I plus 1, so that's negative 2.5. V of I is 50. And yes, negative 2.5 is less than 50, so we need to swap. So we swap, and I'm going to summarize this here. After the swap, we get negative 7, 50, nope, negative 2.5, 50, 100. And so that's the end of the swapping routine. Now, then we get to the for loop. We'll come back up, set I equal to 3. And we say, if v of I plus 1, so v of I plus 1 is 100, and v of I is 50. So is v of I plus 1 less than v of I? No, it's not. So we do not enter the swapping routine. And the for loop now is done as well because I was 3, and I has a maximum of 3 in this case, length minus 1. So we kick out of the for loop, and we go to the while loop, and swapped was 1 from previously. We say, did we swap something on that pass? Yes, we did. So we come back up and we say we have to swap again. So we're going to reset swap. Okay. Set I equal to 1. V of I plus 1. So that's negative 2.5. V of I is negative 7. Is, or if, v of I plus 1 is less than v of I. So is negative 2.5 less than negative 7? No. So I don't swap. And I get to the end of the if statement. Now the end of the for loop, I come back up and I let I equal to 2. Is, or if, v of I plus 1, which is 50, less than v of I, which is negative 2.5. No. So I don't swap anything. And I go back to the if. I come back up and I make I equal to 3. V of I plus 1 is 100. V of I is 50. Is v of I plus 1 less than v of I? No. Okay, and I've ended the for loop, and I made no swaps on that pass. So now we come to the while loop. We say while swapped equals 1. Well, swapped is not 1, it's 0 because we never swapped anything. So now we kick out of our while loop, and that is the end of the function. And so here's our outputted vector there. And it's sorted. Let's see if it works. So I'll say v equals, say negative set, our original vector was, darn it, I don't really remember. I think it was 100, 150, negative 7, negative 2.5. So let's do that. So I've got that guy there, and I will call, I guess going back up to my code, the last thing I have to do is set v of s, our output, equal to v. So now I want to output that sorted vector. So there's my vector v, and I'm going to call my sort and give it v, and lo and behold, it outputs the sorted vector. Pretty neat. All right, let's test it with a different sized vector. So we'll give it v equals, how about a random permutation of the numbers 1 through 50. So there's our vector. Okay, it's got 50 numbers, and they're all randomized. So we'll call my sort, and we'll give it that vector. And look what I've got. It's sorted. Okay. Now you might want to know, one thing you have to get used to is testing your functions with a lot of different test cases, particularly cases that might break or cause errors to your code. So we've seen that it looks to be working, but one type of vector that might break our code is one that's already sorted. Let's see what happens if we were to give this thing a vector that is already sorted. So how about we give it about 0, 10, 25, 100, 1000. Let's see what would happen in this case. So on line 6, length would be 5, or len would be 5, because the length is 5. On line 8, swapped would be 1. While swapped is 1. Okay, so we enter the while loop, and then we're going to reset the swapped flag to 0. For I equals 1 to 4 in this case, so I becomes 1. V of I plus 1 is 10. V of I is 0. So is V of I plus 1 less than V of I? No. So we skip the swapping routine and we go to the end of the for loop. We come back up and set I equal to 2. Okay, we look at I equals 2, V of I plus 1. So with I equal to 2, V of I plus 1 is 25. V of I is 10. And we ask is or if V of I plus 1, 25, less than V of I, 10. No. So we skip that swapping routine, go to the end of the for loop, come back up, and set I equal to 3. With I equals 3, V of I plus 1 is 100, and V of I is 25. We say if, we're going to swap if V of I plus 1, 100, is less than V of I, 25. Well, that's not the case, so we don't swap. We get to the end of the for loop, set I equal to 4. With I equal to 4, V of I plus 1 is 1000. V of I is 100. If V of I plus 1 is less than V of I, swap. Well, that's not the case. So we do not do the swapping routine. We come to the end of the for loop. And this for loop was only supposed to run until I got to len minus 1. Well, len is 5. Len minus 1 is 4. And I is 4. So that's it. So now we come to the end of the while loop, and we look at swapped. Well, swapped is 0 because we never performed a swap. And so we kick out of the while loop, and that's it. We output this guy. So it should work. Let's check it out. V equals 0, 10, 25, 100, 1000. Okay, call my sort V, and lo and behold, it works. So that's all there is to it, right? So just one note is that we don't have to stop at 2 loops. We can have as many nested loops as our function requires. 3, 4, 5, 6 loops. All right, but let's summarize some key points here. And there really aren't too many key points in this time around, because if you understand the for loop and you understand the while loop separately, then the nested loop should not come as any surprise how it works. But we'll summarize anyway. A nested loop is a loop within a loop. And the innermost loop is evaluated completely before the outermost loop. Yeah, there isn't too much more then to say. Again, if you understand how the loop works, there's nothing too much more to say. If you're using 2 for loops, you should have different iterators for each nested for loop. Different iterators, so I and j for the first example. And then finally, you should be able to, like we have done here, make a table. You should be able to make a table and keep track of the values of these key variables through each iteration. And for a certain function call, you should be able to work through this and determine how many times your code will loop. So how many times will the for loop loop for each while loop? How many times will the while loop loop? And so how many iterations are there total? You should be able to answer these questions. So I'll just write keep a table. Keep a table of important variables and be able to answer the question, how many times will the code loop? That's code right there. If this gets cut off, how many times will the code loop?